ሰላም ውድ የቻናላችን ተከታታዮች፣ በዛሬው ቪዲዮአችን ሂት የሚለውን ይዤላችሁ ቀርብ ያለው። ከዛ በፊት ቪዲዮአችንን ላይክ፣ ሼር እንዲሁም ሰብስክራይብ እንድታደርጉልን በአክብሮት እንጠይቃለን። ወደ ቶፒካችን ሂት ኢዝ a form of energy that transfer or that flows from higher temperature to the lower when two bodies are in thermal contact with each other. There are different forms of energy like light, heat, electrical, mechanical. From these forms of energy, heat is one form that flows from the higher temperature to the lower temperature. From this temperature indicate the direction of heat flow. If two bodies are in thermal contact with different temperature, for example A at 100 degrees Celsius and B at 70 degrees Celsius, therefore heat flows always from higher temperature to the lower temperature. Heat is measured using a unit. It is measured with a unit, joule and calorie, so and so on. And 1 calorie of heat equals 4.2 joule. Now let's see effects of heat. Mainly, when a body gets heat, there is increase in temperature, or the temperature of the body rise. The second effect of heat, there is what? Change of state, which means from solid to liquid. For example, if we take ice, is in a solid state, it changes to liquid water, and when it gets heat again, it changes to steam or vapor. The third effect of heat, which is expansion, in this case it is increase in size. When we say expansion, there might be expansion in length. Such expansion is said to be a linear expansion. A linear expansion, which is increase in size, For example, if we take a copper wire here, and with length 1 meter, again let's take a copper wire which is 1.5 meter, the same substance. When it gets heat, there is an expansion, but this change in length is different for such cases. When length decrease, change in length decrease, original length increase, also change in length increase. In your mathematics lesson, change in length is directly proportional to the original length. There is a proportionality constant which you are discussed in your mathematics lesson. And the second effect, the same kind of material, both copper, here again copper, the same kind of material and the same length 1 meter, here is again 1 meter. But when heat at 70 degrees Celsius, the first one, and the second one heat at a temperature of 100 degrees Celsius, changes when temperature increase, change increase, when temperature decrease, change decrease. From this, change in length is directly proportional to change in temperature. Let it be equation 1, let it be ይሄኛውን equation 2. Now delta L is directly proportional to original length and change in temperature. In your mathematics, again, y directly proportional to x, there must be some constant k which satisfy this equation. Similarly, there is a proportionality constant called coefficient of a linear expansion, and it is denoted by alpha. And this indicates coefficient of linear expansion, which is mathematical meaning, the physical interpretation of proportionality constant, which is types of material, type of material. Hence, change in length depends on original length. Change in length proportional to change in temperature. Also, change in length depends on type of materials, which means if we take two materials, the first one made of aluminum and the second one made of copper, will not increase in length with the same rate, which means different materials have different coefficient of linear expansion, which is shown below. From the above table, we observe that different materials have different coefficient of linear expansion. Hence, mathematically, delta L is equal to alpha L naught times delta T, where alpha is a coefficient of linear expansion, the unit of coefficient of linear expansion is, for example, if we take this equation, alpha equals delta L over L naught times delta T. The unit of delta L and L naught, which is the same meter, which cancel. Hence, the unit of coefficient of linear expansion is per degree Celsius or per Kelvin is the unit for coefficient of linear expansion. Similarly, there is surface expansion or area expansion. Hence, change in area equals, in this case for surface expansion, the proportionality constant, which is beta times A naught times delta T, where beta is a coefficient of surface or area expansion, and also for a volume expansion, change in V equals gamma times V naught times delta T, where gamma is coefficient of volume expansion. And we have a relationship between gamma, which is 3 times alpha naught, and also beta, which is coefficient of surface expansion, equals twice of alpha. Now let's see example related on it. Now let's see example. Metal A has coefficient of linear expansion that is 3 times the coefficient of linear expansion of metal B, which means coefficient of linear expansion of A is equal to 3 times coefficient of linear expansion of metal B. How that their coefficient of area expansion, which is beta of A and beta of B, how they compare each other. Now beta of A, which is coefficient of area expansion of A, equals, from the above equation, beta of A equals twice alpha of A, and coefficient of surface expansion of metal B equals twice linear expansion of metal B. But here we have alpha of A equals 3 times alpha of B. This implies that 2 times alpha of A equals 3 times alpha of B. And here beta of B equals twice alpha of B. Now take the ratio. When we take the ratio and beta of A to beta of B equals twice 2 times 3 times alpha of B over 2 times alpha of B. Alpha of B cancel alpha of B, 2 cancel 2, then we have beta of A over beta of B, which is surface expansion of A divided by surface expansion of B, equals, here we have 3. If we take this to the right, then beta of A equals 3 times beta of B, then choice B is the right answer. This is taken from 2009 entrance exam.